What happens in an IARC meeting is that initially out of subgroups will come a recommendation from the animal group and the human studies group that at least they would recommend that something be placed in limited, sufficient, and adequate, one of the three categories there. And that would come from the human study for the epidemiology, human studies group for the epidemiology, and the equivalent for the animal studies. But then they have to convince the entire working group of what their position is, and usually there's people are asked to read the documentation. Summaries are produced of that documentation. There's a brief presentation of the evidence, and the chair of a particular subgroup will present to the group what they believe is the opinion of the group based upon the discussion. So it might be there, for instance, that they might say, well, our subgroup is actually split on this subject of this particular area, or the group is unanimous in feeling that it should be placed in this particular category. And then it goes to the entire working group to discuss where they think it should fall. And then there's a vote of the entire working group. And they will vote as to whether something falls into generally one of these three categories for cancer in animals and one for humans. And then what you see here is that depending upon that, there's kind of a default evaluation that ends up coming up. Now, if we see something that we believe is sufficient, that we really have been convinced that we have sufficient evidence for causing cancer in humans, it really trumps all. You can see here that positive human studies will simply carry the day, and something ends up in group 1. But if we look at it and we say, well, there's a pretty consistent picture here, but we're not quite ready to draw that conclusion, or and this is a pretty broad range here, this limited, then whether or not the animal studies are positive or not then begins to play a role. And it plays a much bigger role when we say that there's inadequate information. So this is the kind of initial, what we call a default evaluation. It isn't the final evaluation because there's another level of discussion that happens, particularly in current meetings, where you see that mechanistic and other relevant data is brought in. We look at the strength of the mechanistic data. How much do we know about how a particular agent might cause cancer? Has it been well established? Can we describe it? Do we know all the steps? And is it likely to operate in humans? Then is the next question. So even if our group of experts feel like, well, we understand how this would cause cancer in rats or mice or some other type of animal species, they still have to have a further discussion of, is there evidence that this is likely to occur in humans? And so there's another second bar that would be carried up with that. Now, based upon that, and I give an example, if something were in this category and the group really felt that we know it's happening in animals and we don't see any reason why it wouldn't happen in humans, there's evidence, we understand this well in animals, there's evidence for this working in the different stages in humans, and if that argument can carry the day, something can actually be upgraded, even if there's very little human data, to going to 2A from 2B. Now, occasionally there are also situations where people say, well, this is a very weird mechanism in the animal studies, we don't really think it applies to humans. Then the opposite can happen. If there's no evidence in humans, it can actually downgrade something down to a group 3 if they think they understand it, but it doesn't work in humans. So it can move things by generally about one category if it's strong enough to make any definitive statements. And that's not always the case. It's only a case was used to be very rarely the case. It's becoming a little more common now, but it's still a relatively, isn't the most common occurrence. So what you can see here is that with that kind of evaluation, with the fact that you would consider the human evidence limited and the cancer and experimental evidence, the default evaluation here is already that it's a probable human carcinogen. But let's say the human evidence didn't convince as many committee members, and let's say it had gone to inadequate. Then it would have been a possible human carcinogen. It would have been 2B, or at least that would have been the starting point. But then there's the discussion of plausibility that comes into place, and biological mechanism and things like that. In order to, if it was at the lower level, in order to go up, you'd have to say that there's strong evidence that that this mechanism would actually work in humans. I mean, one of the things that I want people to remember is to look very closely when you look at evaluations, that the final evaluation for this was not Shiftwork. It was Shiftwork involving disruption of circadian rhythms, and that is the definition that we ended up at, which is trying to get closer to what we thought was actually potentially happening. But when something is classified as a possible or probable carcinogen, it means that there's a lot of issues that are unresolved that have to be thought of. It isn't a simple thing, and it's very easy to kind of take a black and white interpretation. So I'm hoping that people will pull away from this meeting the idea that it's important to read closely as to what's being evaluated and give that some thought. An underlying goal of this also is that IARC's classification of carcinogens really plays a very key role in cancer prevention in terms of setting policies and regulations, and an underlying goal of this is to develop a better understanding of that so that we know better how these classifications can and should be used. The ways that IARC kind of contributes to prevention, I've kind of tried to summarize here. Many years ago, just after I got my PhD, I actually spent a year at IARC, and during that time, they had just produced a survey that I haven't seen replicated since. But what their survey indicated that when IARC classifies something as a carcinogen, at that time, 127 countries changed their regulations. So there was an impact really pretty global in reach in terms of changing the policy and regulation of carcinogens. So the impact of these classifications is very broad. It can certainly help set priorities, even if it doesn't change research. Many organizations certainly reevaluate what their policies around a particular agent when it's classified as a carcinogen. In Canada, we have some very specific things that happen, so that, for instance, our material safety data sheets are required to list when something has been classified as an IARC, carcinogen or probable even possible carcinogen. That's supposed to appear by regulation on the material safety data sheet. It certainly also impacts workers' compensation policy, particularly when something is classified as a definite human carcinogen, generally raises awareness, and even at times results in a lot of voluntary reductions in exposure. I know that I've looked at some analyses of monitoring data that's been collected by different regulatory agencies, and they notice a blip, at least in reductions in levels that they're measuring in the years following the classification of something as a carcinogen. One issue with the classification of carcinogens, as useful as I think that is, and it's perhaps a bit unique to cancer that we really use classifications a lot, Canada really has no independent body that sets that. Indeed, most countries do not. The United States uses the U.S. National Toxicology Program, which actually operates in pretty close collaboration with with IARC and its classification. There are some organizations that make recommendations on occupational exposure limits that also list whether categorize carcinogens, such as the ACGH TLV committee, which is one that's also used quite a bit across Canada. There's some other organizations that do similar things, such as in Germany or the Netherlands. But certainly the most widely recognized internationally is the classification used by IARC.